Yes.
Good evening.
Yes. We're just waiting for a few more students to join, and then we'll
Ma'am,
start. You're not audible, Sangeeta.
it's
The voice is breaking. I'm not able to hear you.
not audible now.
Yeah. Good evening.
This is not related to a content, ma'am.
Related to? Sorry, I'm not able to hear you. If you have any question, maybe you can put in the chat. So now we are just waiting for more students to join. Maybe I can start in 3 more minutes. Then we'll start.
Ma'am,
Yes.
ma'am, I have a doubt in activity question 12.6.
Okay. I will take that. Let me first
Uh,
start with the solve with a session.
okay. Cool.
Okay. Let's start now. So this is the code for to join the peer deck session for week 12. So go to joinpd.com and again use this code that you can see on the screen, ATIMLX. Okay, I see one student have joined. Others, please join. Okay, let's start now. So just to so in week 12, you have looked at all the continuous distributions where you saw a uniform distribution, exponential distribution, normal distributions, and so on. So we'll solve the questions from these topics. I hope the deadline for the grade assignment is today for you.
Yes, ma'am.
Yeah. Okay. Let's proceed. So the first question, it says the lifetime of a light bulb is exponentially distributed with a mean life of 18 months. Okay. So what is the random variable here? The random variable is lifetime of a light bulb. Okay. And that random variable, if I'm saying this lifetime of a light bulb is x, the random variable x. So x is exponentially distributed with mean of 18 months. All right. Now, if you have a 60% chance that any light bulb will last for at most t months. So when we say at most t months, what do we mean? It means maximum that any light bulb will last is t months. Okay, so it should be less than equal to t months. Then you have to find out what should be the value of t. I will give some 3 minutes. All right, so I see only 3 students have answered the question. Um, so all of you have said whoever has answered its third option is right. Um, so what is like how are you going to solve this? So does anyone has any doubt in understanding this problem? Okay. So let's proceed with the solution then. So what all first we should see what all information is provided to us. So what we are saying is that the mean life is given to us as 18 months. We know that for exponential random variable, the mean is given as like if my random variable x is exponential lambda, then my mean is 1 upon lambda, right? So in our case, since mean is given to us, so the lambda, the parameter should be 1 upon 18, right? Now, if there's a 60% chance that a light bulb will last at most 3 months, then what is the value of t? So what we have to find is probability that x is less than equal to t is equal to 0.60. That is our probability. Now we'll just use the CDF of a exponential random variable, and from there we can easily find out the value of t. So let's see how it is done. Yeah. So as I said, like mean of the exponential random variable is given to us as 18 months. So my lambda should be 1 upon 18. Now, since probability of x less than equal to t is 0.6, and we know the CDF of a continuous random variable is nothing but 1 minus e to the power minus lambda x. So in this case, it is going to be 1 minus e to the power minus lambda t, which is 0.6. So e to the power minus lambda t is going to be 0.4. Now, since we have to solve for t, so one natural way to do it is like you take the log on both the sides. So after you take the log on both the sides, what will happen? You see this log of e to the power minus lambda t will become just minus lambda t. So minus lambda t equal log of 0.4, right? So this is what we are going to do here. Yeah. And then solve for it, and you should get the third option is right. Any doubt in this question?
Ma'am, after taking log, could you please explain the step once again?
After taking the log,
Yes, ma'am.
okay. So after you take the log, what will happen? So log, you will get minus of lambda t equal log of 0.4.
But
Where
ma'am,
did
it's no
minus?
money.
Yeah, where did minus go here? Hold on.
Ma'am, it will be minus ln of point 0.4, which we have to convert like using log m by n formula.
Yeah,
We have to reverse it,
something like
then
that will
then
come.
we will
Yeah,
get ln of
yeah, yeah.
2.5.
Yeah, maybe wait. I will just uh, do the calculation. Yeah. Are you able to see my screen?
Yes, ma'am.
Okay, see now what we have is e to the power minus lambda t equal 0.4, right? So if I take the log on both sides, I get minus of lambda t equal ln of 0.4, right? I can take the minus on this side and I'll get this. So lambda t equal, I can take this minus over here, right? So what is 0.4? 4 by 10. So it will be 2 by 5, right? 2 by 5 is 25 by 1, 25 by 10. How is it 25 by 10?
Ma'am, it becomes a 2 by 5 minus log
Hmm?
minus log of 2 by 5, which is same as ln of 5 by 2, which
Okay,
becomes
that's how it becomes
ln
2.
of
Right,
2.5.
right, 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 right. Yeah, correct. Yeah. So now this can be
Is
written
ln
as,
n by
yeah, ln of 5 by 2. Ln of 5 by 2, right? So this is, so t becomes 1 upon lambda ln of 2.5. Yeah. So 1 by upon lambda, we knew it was 18. So my t becomes 18 times ln of 2.5.
Ma'am, there is a property of log. If there was a negative log a by b is equal to log b by a.
No, I mean, there's nothing like that. I mean, it is just, you know this, right? Like log of a to the power b, you can write it as b of, or log of x to the power b is b of log of x. You can write, no?
Yes, ma'am.
So the same thing it has been done here. So log of 2 by 5. Here it is minus, so it is taken over there. So the inverse is 5 by 2. It's fine.
Yes, ma'am.
Okay. Let's move to our next question. Are you able to see the screen?
Yes, ma'am. Ma'am, could you show last previous slide one more time?
This slide. Yeah.
Ma'am,
Hmm.
previous slide.
Previous slide. This one.
Yes, ma'am.
Should I, can I proceed?
Yes, ma'am.
Okay. Okay. So here, you have a random variable x whose PDF is given to you, and what you have to find is the probability that call exceeds the mean time. Give you some time. Okay, so we have three different answers for this question. How do we approach this question? Like, um, can someone tell me?
Ma'am, we know that fx is defined as x e raised to man power
Hmm.
minus lambda x for
Hmm.
a exponential distribution.
Hmm.
So we'll compare, we get lambda is equal to 1 by 2.
Hmm.
So that we get expectation of x is 2.
Correct.
So we have to find out probability of x greater than 2.
Yes, correct. Exactly. That is what we have to do here. So the PDF of a random variable x, which is defined as the time between calls and the customer care. And if you look at the PDF, you will realize this is nothing but a exponential period, right? From here, if you compare this 1 by 2 to the power minus x by 2 with lambda e to the power minus lambda x, you will see that the lambda is nothing but 1 by 2 in our case, right? So, okay, so now we figured out that, okay, my this random variable x follows exponential lambda 1 by 2. Now, and we also know that for an exponential random variable, the mean is 1 upon lambda, 1 upon lambda. So the mean for this case would be 2. Now, to find the probability that time between calls exceeds the mean time, so what we have to find is probability that x is greater than 2, right? So this is just calculate that. So we have to find probability x greater than equal to 2. And that is just what was the answer that you guys gave? Okay, B was the correct answer. Fine. So yeah, exactly what we have done over here. So mean time is 1 upon lambda. So we got the mean to be 2. And what we have to find is probability x is greater than equal to 2 now, right?
Ma'am, how we know we need to find probability greater than 3?
Because when yeah, because if you look at this question, it says find the probability that time between call exceeds the mean time. So exceeds the mean time means what? It means the time, this x should be greater than equal to the mean time that you got,
Yes, ma'am.
right? And what is that? That is 2. So that is why we are finding probability x greater than equal to t. So basically it's 2 here. And what is probability x greater than equal to t? Okay, here it has been written very direct. So what you can do is, so you can also do the integration or not integration. What you can do is you can write this as 1 minus probability x less than equal to t, right? And when you write probability x greater than equal to t as 1 minus probability x less than equal to t, so you know this probability x less than equal to t is just the CDF of the exponential. And the CDF of the exponential is given as 1 minus e to the power minus lambda t, right? So from there, 1 gets cancelled and we can directly write e to the power minus lambda t, right? And our case, this lambda is 1 by 2 and lambda is 1 by 2 and t is 2. So what we are left with just e to the power minus 1. And e to the minus 1 is nothing but 0.368. Any doubt in this question?
No, ma'am.
Okay, we'll move to the next one. All right. The question here says, the time that the Jan Shatabdi Express will reach Delhi station is uniformly distributed between 12 p.m. to between 12 p.m. and 2 p.m. So we can define a random variable x that denote the time taken by the Jan Shatabdi Express to reach the Delhi station. That is my random variable. And what we're saying is that this random variable x is uniform over 12, comma 2, right? So now the question is, what is the probability that train reaches to Delhi exactly at 12:30 p.m.? It's quite simple. I'll just give 1 minute for this question.
Hello, ma'am.
Yes.
Apart from this question session, do we have a 12th week live session?
It has already happened, I guess.
Okay.
It has happened. One session has happened on Friday, one on Sunday, and this is the third session for week 12.
Okay. Thanks. Let me check.
Yeah. See. 01.25. Okay. What do you think is the right answer? 0.25 or 0? Okay. Is this a continuous random variable or it is a discrete random variable?
Continuous.
Continuous random variable, right? So since it's a continuous random variable and you would have like studied this in like when you're watching the lecture, you would have looked at this that uh, the PDF at any point is 0, right? So here we are asking for probability x equal to 12 at 30 minutes, right? So we are asking the probability that the train reaches exactly at 12:30. So probability at x equal to 12:30. So that will be that will be 0, not 0.25. So in this case, like just to give you an idea of like the area under the curve. So if you take the PDF effects and you integrate it with between this point 12:30 to 12:30, you see it's just going to get cancelled out. You don't even have to do this much because you know that our random variable is a continuous random variable and we know the probability at any single point is 0 in that case. That is why the answer for this question is 0. Okay. All right. Now let's look at the next question. It says the total duration of a badminton match in the Premier Badminton League is uniformly distributed between A and B. The variance is given to you, and the probability that so one probability is also mentioned, like the probability that match will last at most 42 minutes. So probability that x is less than equal to 42 is 1/3, right? Then you need to find the expected time duration of a badminton match. So to solve this question, you need to know for a continuous uniform random variable, how do you define the variance? How do you define the expectation? Okay. So once you know that, you should be able to do the calculation and find out the answer. All right. Okay, 4 responses, all 4 different answers. So what is given to us here? We are given, so first of all, how do you define the random variable? So we can define the random variable X as the total, the time duration of a badminton match, right? This is how the random variable is defined. So X is, let X denote the time duration of a badminton match. And it is given to us that X is uniformly distributed between A to B. Now the variance of X is given to be 3 square minutes. And you have to find the expected time duration. It means you have to find expected value of X. Since the variance of X is given, and what is the, like, how do you find out the variance of a uniform random variable? It is B minus A whole square by 12, right? So, and that B minus A whole square by 12 is given as 3. And for the expectation, you need to, it is A plus B by 2, right? So we need to know what is basically A and B. Once you know that, you can find out the probability, you can find out the expectation. To do that, we also need to utilize this information that is given to us, that probability that X is less than equal to 42 is 1 by 3. Let's see how we are going to solve this. So the first information, that variance is 3. So from there we get B minus A whole square by 12 is 3. Now B minus A whole square becomes 36, right? So from B minus A whole square 36, we can say this B minus A is either plus 6 or minus 6. We don't know what is B minus A is. So we'll have to take into consideration both the cases. Let's proceed. Now, the second information that is given is probability X less than equal to 42 is 1 by 3. Now, probability that X less than equal to 42 or 42. So how do you define the CDF of a CDF of a continuous random variable? It is X minus A upon B minus A, right? This is how you define the CDF of a continuous uniform random variable. So from there, I mean, we know that probability X less than equal to 42. So we can write this as 42 minus A upon B minus A. And this we are able to write because of the CDF of a continuous uniform random variable. So this is 1 by 3, right? So from here, what do we get? We get 42 minus A equal to, so 42 minus A. We have, as we had seen in the previous, the variance case, that B minus A can either be plus 6 or it can be minus 6. Okay. So what we have done is we have taken B minus A to be plus 6 and not minus 6. Why is that? Because if we do the other way around, then A becomes less than B. So that is not right. So you can write, so let's say B minus A is minus 6, right? So if B minus A is minus 6, let me just, we can share the other screen. See, what we got is, we got B minus A to be either plus 6 or minus 6. And we have probability X less than equal to 42 is 1 by 3. Okay. And we know that the CDF of a continuous uniform random variable is X minus A upon B minus A. Now in this case, my X is nothing but 42. This is 42 minus A divided by B minus A equal to 1 by 3, right? Now what is 42 minus A? 42 minus a becomes b minus a times 1 by 3. Now, from here, I can take both the cases. So first, let's solve for when b minus a is plus 6. So when b minus a is plus 6, we get 42 minus a equal to 2. That implies a equal 40. So if a equal 40, my b would be 6 plus a. So that would be 46. Now, if I take b minus a to be minus 6, then what happens? We get 42 minus a to be minus 2. And that implies a equal 44. And from here, what we get is b equal minus 6 plus a. So this becomes 38. So what we are saying is a is 44, and b is 38, which is not right? Because my the interval is a comma b. So a should always be less than b. So we'll discard this case. So my b minus a should be 6. Okay. So considering that my b is 6 plus a, b minus a is 6, we got a to be 40 and b to be 46, right? So just use these two. And to find the expectation, I know that it is just b plus a by 2. So we can just solve for that and we get 43 as the right answer. Okay. Is this clear?
Yes, ma'am.
Okay. Whoever has answered 43 is right. Now we have, okay, again a question from a uniform random variable. So it says, suppose the random variable is uniformly distributed over AB with expectation as 6 and variance as 4, then what is the value of A times B? This is the need to find.
Ma'am, could you give more time?
Okay. I give another 3 more minutes. Okay, let's see. All right. So here, like in the previous question, we had to find expectation. But now here, both the variance and the expectation is given, and we need to find what is this A and B, and then find the product AB. Or maybe there is some other way with which you can find AB. So we'll just use the formula. There is nothing else that we can do over here. So we'll just use the formula for both the expectation and variance. So expectation of x that we know is given by a plus b by 2. And since it is given as 6, from there we got a plus b to be 12. Now the variance of x, which is b minus a whole square by 12, and it is given as 4. So from here we got b minus a whole square equal 48. So what just one trick that we have used here, like we could have also done like substituting this a plus b equal 12 into this equation, like either the value of a or the value of b, and solve for this b minus a whole square by equal 48. That way also we could have gotten the value of a and b and found and could have found the product of a times b. Instead, what we have done is we have used a small trick here, And so what we have done is a plus b equal 12. Then we took the square of a plus b whole square, and it is 144. Now use this both information, which is a plus b whole square equal 144 and b minus a whole square equal 48. So we are just going to do this, we're just subtracting these two. So from there, like once we solve for it, you will get 4ab, which is 96. So once we get 4ab equal 96, we can easily get ab to be 24 from there. So 24 is the right answer. Any doubt here?
Yes, ma'am. Can you explain it again?
Which part did you not understand?
Why we are putting, why we are taking a square this side?
Not required. And that's what I said. It's not required. It's just a trick that we have used. So what you could have also done is, let's say you got a plus b equal to 12, right? So from there, let's say I'm going to take b equal 12 minus a.
Yes, ma'am.
Huh? Then I put just this b to be 12 minus a in this equation.
Minus 8
Whole square. Yeah, so b equal 12 minus a. So 12 minus 2a, the whole square equal 48. We could have written that and then solve for quadratic equation, and then could have found the values of a and then from there value of b. But instead of doing all that, what we did is we took the square of a plus b whole square equal 144, and then we subtracted both these terms. So we subtracted it. I mean, we know that a plus b whole square equal a square plus b square minus 2 plus 2ab, and b minus a minus b whole square is just minus 2ab. So if we subtract it, I know this square term will get cancelled out, and we will have this ab term with some constant along with it. So that is what we have done here. This way, this is much easier and faster. Is it okay?
Yes, ma'am.
All right. Okay. Again, a question from a uniform random variable. So the PDF, how it is given it is, we are saying the PDF of this uniform random variable is k for mod of x less than equal to 5. Okay. And if not, it is 0. So what is this k is what you have to find. A little tricky. I mean, if you find the interval right, then it's quite easy. Just think about it.
Hello. Hello.
Yes.
Yes, ma'am. Am I audible to you?
Yes, you're audible.
Sorry, ma'am. Just lose connection. Um,
Tell
yes,
me.
the previous question. I solved this question. This is actually given in the graded assignment 12.
Okay.
This type of question. But at there I stuck in that question because the same if I solve it simply by putting the evaluating the value of a and b, then the answer is not right.
By simply evaluating the value, finding the quadratic equation and then solve for it. Is it what you mean? I think I lost you again. Let's see the responses for this. All right, three different answers again. All right. So first, see, you have mod of x less than equal to 5. For that, the PDF is defined as fx equal k, otherwise it is 0. So that mod of x less than equal to 5 is nothing but your x lying between -5 to 5, right? I hope that is clear. Mod of x less than equal to 5 is nothing but x lying between -5 to 5.
Yes,
Right?
ma'am.
So for that interval, for that particular interval, my fx is taking the value k, otherwise it is 0. All right. So what is k going to be? And since we are saying that fx equal k for x -5 to 5, it means, and x is nothing but a uniform random variable, in continuous uniform random variable. So the PDF is going to be 1 upon b minus a. So in this case, my b is 5, a is -5. So b minus a is 10. So k is nothing but 1 upon 10. So that is my answer. Is it okay?
Yes, ma'am.
Okay. Next question is the PDF of a random variable x is given to you as fx equal kx for x lying between 0 to 1, 0 otherwise. Now you have to find the value of probability of point that x lying between 0.2 to 0.8. To find that, the first thing that you will have to do is to find what is my constant k. So this might take some time. I'll give you. Okay, I will first give it 3 minutes. If not, we can extend this.
Ma'am, which distribution is this?
That is not given to you. The only thing that is given is I have a random variable x. The PDF of this random variable is kx for x lying between 0 to 1, otherwise 0. So now you have to find the value of probability that x lies between 0.2 to 0.8.
Ma'am,
Hmm?
That Means this is
Sorry, ma'am.
non-uniform or triangular. We have to
Yeah, it's non-uniform. I guess so.
I mean, there is no name for this. I mean, don't say it is a non-uniform or something. There is no name. It's just some continuous random variable. It is not a known random known distribution. It is some random variable, continuous random variable, and you have to find out min. You have to find out what is the probability that x is between 0.2 to 0.8. And to find that, you need to know what this k is. The first thing you have to do is to find this k.
Ma'am, can we go back to the previous question? The way I'm asking my
Uh,
doubt.
Let us finish this first because we have already
Okay.
moved 2 questions from there.
Okay,
After
ma'am.
this, I'll go back.
Okay.
So here the first question that you need to solve is what is k? The hint is given to you. Just think about it.
Ma'am, please give one more.
Okay. Let's see. 6 different answers. 6 people have responded with 6 different answers. Okay. So how do we solve for this question? We needed to find the probability that x lies between 0.2 to 0.8. And what exactly is that? So as I said, for that we need to know what is my k, right? So you have to just use the property of PDF, correct? So property of PDF, I mean, what does it say? That fx has always, like it is always greater than equal to 0. And the second thing is, it has to be, like the integration over the whole range should be 1. So we'll use this property. So if we integrate fx over minus infinity to infinity, it should give me 1. That is one of the property of PDF. So in our case, fx is defined only over 0 to 1. The rest is 0. So I can just make it 0 to 1, kx dx. And that is equal to 1. And if you solve it, you get this to be k times 1 by 2 equal 1. So from there, k equal to 2. So now, once we found out the value of k, which is 2, so we can say that, okay, my the PDF is defined as 2x for x lying between 0 to 1, 0 otherwise. Now, to find the probability that x lies between 0.2 to 0.8, it is nothing but integral of the PDF dx, where the lower limit is 0.2 and the upper limit is 0.8. We solve for this integration and you'll get 0.6 as the answer. Any doubt here?
No, ma'am.
Okay. This is the last question. It says traveling duration of time taken every day by a train is uniformly distributed between 200 and 220. What is the probability that duration of the time is more than 215 minutes, given that on that day more than 210 minutes of time was taken? Like you have observed that it has already been 210 minutes and um, the travel is not complete. So what is the probability that it is going to take more than 215 minutes? So it is more like a conditional probability. So just solve for this.
Ma'am,
Yes.
ma'am, can you give 30 seconds, ma'am?
Yeah. Okay. 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 Let's see the answer for this. Right. Um, it says so you have to find the probability that duration of time taken is more than 250 minutes, given that it has already taken more than 210 minutes. You have to find what is the probability that x is greater than equal to 50 minutes, given that condition on that x is greater than equal to 210. So we just use the formula of conditional probability. And what we get is, so probability that x greater than 215 given x is greater than 210. So this is nothing but if you take the intersection of these two, it is just x is greater than 215. So probability x greater than 250 divided by probability x greater than 210. And then we solve for these two. I mean, we solve this thing. So we get the answer as 0.5. Any doubt for this question?
Ma'am,
Hmm?
here we put the CDF formula, right?
I mean, you could have used even did the integration, it is fine. But doing the integration takes a little more time. So yeah, we use the CDF.
Okay.
Ma'am, before doing the CDF, we can write as 1 minus probability x is less than 215 like that. That is
I mean, that is same as f of 215, no? So directly we can write.
oh, okay, ma'am.
Hmm.
Ma'am, can you explain this again, the question part?
Yeah, okay. See, in the question, it said, what is the probability that duration of time taken is more than 215 minutes? It means x is greater than 215, given that x, it has already taken more than 210 minutes. So given that x is greater than 210,
Hmm.
right? So since what is it saying is, like, let's say you already know that you have observed that the train has taken the time more than 210 minutes. So let's say some 200 12 minutes or something. So we're just saying, okay, it has already taken more than 210 minutes. Now, what is the probability that it will take more than 215 minutes? So this is more like conditional probability. So we are finding probability x greater than 215 given that x is greater than 210, right? So in the numerator part, it is just the intersection of these two, and that will come out as x greater than 215.
Ma'am, it's a condition question, right?
Right.
So they said ki what is the they are asking what is the probability more than 215 and more than 210?
No, given that it is more than 210.
It's given.
So given that as in was, given that means condition that. So it is probability x greater than 215 conditioned on x is greater than 210. So in the numerator, when you take the intersection of x greater than 215 and x greater than 210, you are going to get x greater than 215, right? Just draw a real line.
Yes, ma'am.
So you will get x greater than 215 as the intersection. Right?
210.
Draw a number line.
Yes, ma'am.
Then one point you mark it as 210, another point you mark it as 215. Now x greater than 210 will also cover x greater than 215.
X greater than 2. Yes, ma'am. Yes, ma'am.
So what is the intersection of these two? It is x greater than 215.
215.
So that is why the numerator becomes x greater than 215.
Ma'am, can you explain my drawing?
Okay. Okay, wait, I will share the screen. See, this is, let's say 210, this is 215. And how is it distributed?
It is in between 200 to 220.
200 to 220.
220.
Now you have to find probability x greater than 215 given that x is greater than 210, right? So this is one event. This is another event. So this is what? This is probability A intersection B divided by probability of B, right? So this is probability that x is greater than 215 and x is greater than 210, right? So this is intersection is what you have to take. So x greater than 210 is this reason. X greater than 215 is this reason. Now you have to take the intersection of these two reasons. Intersection of this and intersection of this. What is common? This is common. This reason is common.
Yes, ma'am.
So I can just write the numerator as probability that x is greater than 215. And the denominator is probability that x is greater than 210. Okay. So now we can solve for it. And it is x greater than 215, right? So 215 to 220. And since x is distributed as uniformly distributed between 200 to 20, you can write it as 1 upon b minus a. So this is 20 dx divided by 210 to 220, 1 upon 20 dx. Okay? And you solve for this and you get, this is times 5, 1 by 20 times 10. And this is 1 by 2, just 0.5. Fine. This is okay?
Yes, ma'am.
Hmm. Okay, so that was our last question. So somebody was asking, hmm,
Yeah.
yeah,
And what's the answer of that question?
0.5.
Fine.
Yeah, somebody was asking this question, right? So let's do it. So let's do it the other way also and see if we are getting the same answer or not.
Yes, ma'am.
So I don't know what question was that, but okay. So there what we got is a plus b equal to 12, and we got b minus a whole square equal to 48. So let's use this fact that
Ma'am, B minus. अच्छा हाँ हाँ ठीक.
b equal 12 minus a, and then
Hmm.
substitute it here. So 12 minus 2a whole square equal 48. So I can just take 2 common from there. So 2 times 6 minus a whole square, right? To 48. So I will have 4 coming outside. So I can write 6 minus a whole square equal 12.
Yes,
Right?
ma'am.
So 6 minus a, yeah. So let's solve for this. So what is this? This is 36 plus a square minus 12a equal to 12. So this will be a square minus 12a plus 24 equals 0. Now, if we solve for this equation, what will we get? So a equal
Ma'am,
minus b plus minus under root of b square minus 4a c upon 2a. So 2a is just what? 2. So you get 12 plus minus 24 times 4 is 96. And if you subtract these two, what do you get? 14 minus 6 is 8. And 13 minus 9 would be 4, I guess. Right? 6, 8, 6, 14.
right, ma'am.
Yeah, right. 48. So under root of 48 divided by 2. So 48, what can we write? We can write 2 times, let's see, 12 times 4 we can write. So 12 times 4, and 12 times 4 can be written as 2 times under root 12, right? Okay. So this is what? This can be written as 6 plus minus under root 12. This is A. So let's use this. So what do we get? We get B to B, since my A plus B equal 12. So B would be 12 minus A. Now, what is A that we got? We got A to be
6 plus
6
minus
under root 12.
root.
So first case, let's take 6 plus root 12.
Hmm.
So that would give me 6 plus under root 12. And sorry, 6 minus under root 12. Right. So if I take AB, what do I get? I get 6. Again, why it is not true is because, see, the interval was AB. And if you're taking A to be 6 plus root 12, then I'm getting B to be 6 minus root 12, which is less than B. So it is a contradiction. So I cannot take this. This is wrong. So what I will have to do is I should take, I cannot take a to be 6 plus sorry,
Root
6
12.
plus root 12. So I will take a to be 6 minus root 12. Okay. So doing this, I get b to be 12 minus 6 minus
6 minus
root 12.
root 12.
So now I will get 12,
6.
sorry, 6 plus root 12. So this seems to be fine. So a is this and b is this. Now what is a times b? A times b is 6 minus root 12 times 6 plus root 12. And a plus b, a minus b is what? A square minus b square.
Hmm.
So 6 square, 6 square minus 12, right? So 26 minus 12, which is 24. So this is, I think, the same what we got using that trick that we used. I hope that is okay.
Uh,
Yeah, we got AB to be 24. And from here also we got AB to be 24.
maybe I did some calculation mistake.
Yeah, it was possible. Yeah. Maybe you can check once where you did wrong.
I checked like evaluating the value of A and B and then putting back to in the equation of the expectation and then calculate the value. Is it equal to A plus B is equals to like 12 or not in that way.
Okay. Okay.
So maybe I did somewhere wrong.
Yeah, just check your calculation once.
Yes, ma'am.
Yeah.
Ma'am, we are taking 6 plus root 12,
6
not
minus
6.
root 12. We are taking 6 minus root 12 to be A.
So what's the limit given? It's not mentioned in the question. So why we are not taking this? This point I'm not understanding.
Why we are not taking 6 plus root 12?
Yes, ma'am.
Because when we took 6, A to be 6 plus root 12, what happened is I got B to be 6 minus root 12. Which is a contradiction, right? I mean, if this is my AB and I am saying my A is bigger than B, which is not right. My A has to be smaller than B. So that is why 6 plus root 12 did not work. So I need to take
Okay.
A to be 6 minus root 12.
Okay, ma'am.
Okay. So that was the last question. Stop presenting. Yeah. Any doubt in any of the questions that we discussed?
Ma'am, when will you upload the link in the calendar, the YouTube?
It should get updated. We'll update it today itself as you have the grid assignment deadline today. Yeah.
Ma'am,
Hmm.
I have a doubt in activity question 12.6.
Okay. Let me see.
The last one.
Hold on. Can you send me the question? I need to. Can you send me the question in the chat?
Let me check. Just a moment.
Yeah.
12.6. Oh, yeah. Shift is.
Did you find the question?
Yes, ma'am. Control V.
Ma'am,
Hmm.
ma'am, I have a doubt in 12.5 last question.
Can you paste your question in the chat?
Yes, ma'am.
Hmm. It only says find the value of probability that x lying between -3 to 9. Do you have any information on what x is?
No, ma'am.
It should be right. I mean, how will you find it? Maybe some question that you have to use, some information about x that you have to use in the previous, that you have used in the previous question. Otherwise, it's not possible. Like, what will you find this probability as if you know nothing about this x? Can you just check once? Okay, coming to your question, Kiran. So it says probability z less than z is 0.85. What is 1.4? Okay, maybe I'm not able to figure out from what you have pasted.
Um, it's not. Uh, I'm not
Ma'am,
able to
last
paste
part
the
I
screenshot.
paste in no.
So let me maybe open the portal. Okay, it is week 12. Which activity did you say? 12.6. Did you say 12.6?
Ma'am, I say 12.5.
No, no, not you. Kiran, what activity you were referring to?
12.6 in the last
12.6, which question?
the last question.
Okay, the last 14th question. So it says, find the value of z such that probability mod of z less than z is 0.32, right? This one, right? This is the one you're talking about.
Yeah, yes, ma'am.
Okay, from there, I mean, you can see that probability, see, what can you write probability mod of z less than z, less than z as? It is nothing but
Um,
this capital Z lies between minus z to z, right? And you know that this z
yeah.
is a normal distribution. So let me be, I can share the screen. Okay. See, my z is standard normal. So z is normal with mean 0, variance 1, right? This is at 0. Now it says probability that mod of z like less than z. So this is 0.32. So you need to find what is this z. Fine. See, if this is 0.32, and we know that your normal distribution is symmetric about the mean, right? So this area should be same as this area. Fine. If that is the case, and we also not know that since this is symmetric, this should be how much? 0.16. And this whole thing, I mean, the area below all this, so this whole thing is 0.5, right? So whatever this is, I mean, whatever this is, this area is going to be 0.5 minus 0.16. And this is what? This is going to be 0.4, not 4, 34. 0.34. So what we got is this minus z. This area is 0.34. So probability that z is less than equal to minus z is 0.34. Means f capital Z of minus z is 0.34. Now, can you look at the normal distribution table and see that what value of z gives you this area 0.34?
Ma'am, not none. I think they start from 0.5.
How? I mean, you will
Value.
have, let me share with you the standard normal table. Yeah, this, I will just take 5 more minutes because I have another class to take. Do you know how to look at the standard normal table?
Ma'am, they've not given the table in the activity question. How do we do, ma'am?
No, I mean in the lecture, ma'am has shown you how to use the table, right?
Yes, ma'am.
Yes, ma'am.
So you need to look at you need to know like how to use that table.
Oh,
So by now, like since you have already learned in the lecture that how do you look at this standard normal table, you should use the standard normal table to find the value. So I'll just tell you. Okay. Okay. See, what we had to find, we need to look at the case, the value for which you're getting the probability as 0.34. So, 0.34 you will get in all the negative values. So let's see. So 0.34 is, yeah, this value, right? You can see this highlighted one. Oh no, this is 0.034. You need to look at 0.34. So 0.34 is, yeah, you have 0.3483. And this you're getting for
Ma'am,
what value?
minus 0.4.
Minus 0.39. Minus 0.39, right? You need to look at the left hand side value, which is minus 0.3. And then you need to look at the top. You need to map these two. And it is given for minus 0.39.
Ma'am, it is at minus 0.4 also.
I mean, okay. I mean, it can be 0.4, minus 0.4 also.
Then which one we have to take? The
Anything.
first
I
one.
mean, anything is fine. It doesn't matter much.
Ma'am, I don't understand, ma'am.
See,
Ma'am, but in the
what we
lecture,
got
ma'am
is,
didn't give
uh,
negative values of Z.
yeah, but it's the same way to look at. That's what we are saying. So till here it is fine, right? Till here it is fine. So
Yes,
what
ma'am.
we are saying is that you need to look at this value of Z, which gives you the probability 0.34. So this probability 0.34 we are getting for what value? So we'll look at more close value. So I think this one is the most close one, which is this value 0.3409. And this, I mean, you are getting the area of 0.34 for Z equal 0.41, right?
Okay, ma'am.
Yeah. So I can say that my Z is 0.41.
Okay.
Okay. All right.
But in our course also, in our lecture also, this whole table is not given. Where is it shared, ma'am?
It is not shared. I mean, you can always find it online. You just search for standard normal table and you will get it. If you want, I can also share with you this link.
Okay.
Or you can just put down like the value. I mean, just put these values in there. There are some calculator also.
But in the exam, they will give this, no, ma'am, this table
In
or
the exam, if it comes, you will get the value. Okay.
okay.
But very simple things about this normal curve you should know. Maybe you cannot expect very simple things. Like, but if it's about giving the values, like let's say here, saying that this value is taken, this area I'm getting at 0.41. I mean, those values should be given in the exam. Okay. All right. Okay, we'll close the session for today. It's already 8.
Ma'am,
Oh,
ma'am, I'm audible.
yeah. Tell me.
Ma'am, this is related to a common question, ma'am.
Mhm.
Due to some personal reason, I couldn't write last end term exam. I have applied for the stats one for the last term,
Hmm.
but I have attended quiz one and quiz two. So due to personal reason, I couldn't attend the end term, and I have applied like for a repeat end term exam alone for a stat one.
Okay.
Whether the syllabus is common for all,
Yeah,
or
common for
I
all.
will be
The
having some.
same. It's the same syllabus.
Okay.
Yeah.
Syllabus will be from week.
Same. Yeah.
Most of the
Week.
questions will be from
Yes.
week
Same.
9
It's
to
the
week
same.
12.
It's same. Yeah.
Okay. Okay, ma'am. Okay, that's
Okay.
right.
Yeah.
Okay.
Okay. Yeah. I will close for
Whether
today.
we'll be having questions
s-
with the week
uh,
1
s-
to
I will close
8?
for now. Maybe I have another session to take at 8.
Okay,
So,
yeah, okay, ma'am. Okay, ma'am. Okay. Thank you.
okay.
Thank you.
Thank you.
Thank you, ma'am.
Yeah, thank you.